Okay, this is Run For Your Life lesson 9. Main theme today is temperature regulation. What we're hoping to get out of this session is, as we've got here for A and A, start explaining explain how the body maintains core temperature with reference to these 4 key terms: evaporation, conduction, convection and radiation. For B grade, explain how negative feedback system works, and then for C grade, recall on what homeostasis is and some of the keywords involved with that. From your spec syllabus, this is what we're looking at. So, although I've not put this in the outcomes, this appears, and you've seen it in a couple of questions already, so toward the end we're going to do this. So describe the structure of muscle fibre and looking at the difference between fast and slow twitch fibres. Explain the principles of negative feedback in maintaining systems within narrow limits. So that's looking at how we control temperature and then how you can apply that to other control systems in the body. And then discuss the concept of homeostasis and its importance in maintaining the body in a state of dynamic equilibrium during exercise, including the role of the hypothalamus and the mechanisms of thermoregulation. So, to start with, what is homeostasis? Well, hopefully you remember a little bit from GCSE. And what we define it as is the maintenance of a constant internal environment. So we're talking about maintaining your temperature, maintaining your water levels, maintaining your ion levels, and maintaining your sugar levels and so on. Now, because animals are multicellular and they're made up of, as it's got here, millions and millions of cells, in order to ensure homeostasis occurs, the cells have got to be able to communicate with each other. The main methods for communication are these things: neurons and hormones in animals, and obviously in plants you've got plant growth factors, which we know bits about, and we've dealt with some of that already, but what we're focused on really today is neurons and hormones. What you need to be able to do is understand how the body controls its core temperature, how it keeps it within set limits, and then how it would respond to exercise as a result, and why that's so important. Okay, so a quick video I found from the bostonchannel.com section on YouTube, and it's about the effects of heat exhaustion on athletes. There's lots of stats and lots of figures of, particularly the, I think it was 1984 Olympics, of the effects of heat on marathon runners in particular, because they exercise for such long periods. But I thought there's an example of here of not an elite performer, but someone who has run a few marathons and then really struggled with the heat because it was a particularly hot day during the Boston Marathon. I'll let you have a listen.
Yeah, Ed, he says he would do it all over again, even though he ended up right here. This guy was in such bad shape, he actually had to be submerged in an ice bath. He was taken to the ICU, and now he's staying here for day number 2.
I had some shortness of breath, which wasn't the usual for me.
As IVs pump fluids into him, 3-time marathoner Vincent Clossy recalls the run that put him in this Newton Wellesley hospital bed.
My feet were heavy, and it was putting me off trying to talk, and I got confused. It was like someone was speed walking. They were all going past me.
Vincent came all the way from Dublin, Ireland to run the Boston Marathon with his father and brother. He didn't think the weather should stop them.
You have to push yourself. What doesn't kill you will only make you stronger.
But the heat did almost kill this fit 29-year-old. He passed out at mile 14, had a body temperature of 105, and suffered heat stroke. He was one of 2,800 runners needing medical treatment yesterday. 9 are still in critical condition, a fact that the chief medical officer at Newton Wellesley finds concerning.
We've got to, in this day and age, prepare times to run this that are a little bit more consistent with what the human body can tolerate.
It was tough, you know. I had never felt that before.
And we called the Boston Athletic Association to figure out whether or not they ever even looked into changing the start time of the race. They say they did consider it, but because of logistics, it just simply wasn't possible. Reporting live from Newton Wellesley Hospital, Kimberly Bookman, News Center 5.
I'm not sure she could have spoken any faster at all at the end there. So yeah, there you go. So a brief kind of insight on the effects of it. If you YouTube heat exhaustion or heat stress, Olympics or marathon or something like that, you'll be able to see a video of the really major effects. I can't remember the name of the athlete, but there was one athlete who just stumbles over the finish line, completely disorientated, and had medical attention instantly because of the effects of the heat. It's a bit of a thing for marathons. They really should be run early in the morning when it's a lot cooler, and not at the middle of the day like when the TV companies want them to be run. Anyway, bit of the science. So negative feedback. Negative feedback is basically where your body has a receptor and it has an effector, and they respond to changing conditions to bring things back to the norm level. So your norm level for your temperature is 37.5 degrees. And so what you have are receptors that receive information about that. They detect the change, and then they cause an effector to bring about a change to either bring that temperature down or increase the temperature, so on. So have a quick look here. So what you've got a receptor, and whatever this is for, you've got a receptor that detects the change in the environment. So a change in the environment is what we will call a stimulus. So it detects a stimulus, change in the environment. If the factor's too low, so following this one here, if the factor's too low, the effector receives information from the receptor, and that will cause the effector to increase whatever that factor is. So if it's your temperature, if your temperature is too low, it increases your temperature. If it was your blood sugar is too low, it'll increase your blood sugar, whatever. Unfortunately, it's not under really, really fine control. So generally what happens is the factor then becomes too high. Okay, so it just goes a bit too far, so your temperature's dropped down to 37.3 degrees, and so it increases up, but it's 37.6 degrees, a bit too high. So your receptor again then receives that information, detects that it's too high, sends that information to an effector, and then the effector decreases the factor, and the factor then becomes too low. And it just keeps happening, that kind of, where you can see it's that kind of cycle, yeah. This is true for whichever factor it is we're talking about. Like I said, the focus of today is going to be temperature, but this is the same for your water, same for your glucose, and so on. So temperature control we call thermoregulation. You need to know that term. Oops. And your core body temperature is 37.5 degrees C. It's slightly less in your mouth, or your armpit, or your ear, where your temperature is normally measured. It's usually about 37 there, but yeah, internal 37.5 degrees. A change of that, so increasing that to, well, by 5 degrees up to 42.5 degrees, can cause death. And likewise, a decrease can cause death as well. So it's got to be fairly tightly controlled. The reason being that if you get too hot, well, your enzymes control all the reactions of your body, and they're going to become denatured, and that's going to stop your reactions from occurring. It's going to cause death. If you're too cold, the enzyme control reactions will happen too slow. You'll not be able to get the energy that you need. It's going to result in death. So it's very, very important that it's tightly controlled. Now, in the hypothalamus, which is basically, if you imagine the very middle of your head, the very centre of your head, just at the bottom of your brain, is where your hypothalamus is, and you've got two parts of that. Well, two parts of the thermoregulatory centre, which is in the hypothalamus. You've got the heat loss centre, and you've got the heat gain centre. Obviously, the heat loss centres, they're there to ensure that you lose heat, and heat gain centres to try and gain heat. So what kind of things will they instigate? So your heat loss centre, well, if you need to lose heat, you're going to start sweating, so your sweat glands are going to secrete sweat. The hairs on your skin are going to lie down, as an example, whereas in your heat gain centre, hairs on your skin are going to stand up to try and trap warm air around you. You're going to stop sweating. Blood is going to be diverted away from your skin, whereas when you're trying to lose heat, blood's diverted towards your skin, which is why you go red, because that transfers more heat to the environment through radiation. You can ignore that bit that I've just covered up with black. It's just from the PowerPoint that I was going to get you to do, but we don't need to do it. So, heat loss, obviously, with regards to losing heat and heat gain to gaining it.